Hello dear viewers, welcome to this video. Today I am going to show you the motor rotational speed measurement using PLC high speed counter and monitor this speed measurement from the TI portal SCADA screen. Here the proximity sensor is used for sensing the rotational speed of the motor. Through this video I will show you the hardware connection of the proximity sensor with the PLC digital input, hardware configuration of the PLC digital input as high speed counter, PLC ladder diagram for high speed counter, and finally control and monitor the speed of the motor from the SCADA screen. The diagram of the project have been shown here. Note that the main job in this project is to run a DC motor at variable speed by PLC analog output signal as well as measure the speed of the motor using PLC high speed counter. For speed measurement, an inductive proximity sensor is placed near the motor disc to sense the motor rotational speed. The sensor gives 2 pulses per revolution of motor disc as 2 metal objects have been attached to the disc. The PLC digital input will receive the sensor output pulses. This digital input will be configured as high speed counter during PLC ladder programming. In SCADA operation, the motor will be run at different speed and the speed will be shown in revolution per minute or revolution per second. To run the motor at different speed, PLC analog output will be used. PLC analog output will be configured as 0 to 20 mA DC signal, which will be converted to 0 to 5 volt DC through the 250 ohm resistor. The Arduino Nano will receive this converted signal as analog input and will give a PWM signal as analog output. Depending on this PWM signal, the driver circuit will vary the motor speed. Let us see the physical devices used in this project. The PLC used in this project is Siemens brand PLC, model S7-1200, CPU type 1214C AC-DC relay. For connecting proximity sensor on digital input of this PLC and for varying motor speed on analog output of this PLC have been used in this project. The proximity sensor here used is PNP type inductive proximity sensor, which only can detect the metal object. The sensor is located near the motor disc, which have 2 number of metal objects attached with it. To convert PLC analog output signal to 0 to 5 volt DC signal, this 250 ohm resistor have been used. This Arduino Nano is used to generate PWM signal depending on the PLC analog output signal. Finally, this is the 12 volt DC motor that will be run on different speed by PLC analog output. Now let's proceed to PLC ladder program for measuring the speed of the motor. First, open the TI portal software and create a new project for the PLC S7-1200. A new project for PLC S7-1200 have been created. Now we will make two configuration settings before we will proceed to PLC programming. One is to make configuration setting for PLC high speed counter, and later is to make configuration setting for PLC analog output, which will give 0 to 20 mA output to run the DC motor at variable speed. Now to make configuration settings for PLC high speed counter, double click on the device configuration tab. The dialog box for device configuration have been opened. Now click on the PLC device to go for the PLC properties. Go for General tab under Properties tab. Here you will find the high speed counter options. If we click on the high speed counter, you will see that there are 6 high speed counters for this PLC. You can select the high speed counter for on to measure the speed of the motor. So click on the high speed counter. You will find some settings for this high speed counter. From the General tab, enable this high speed counter. If we go for function, you will find some settings, that is type of counting. Here we will select the type of counting as frequency. Operating phase is single phase. Then go for hardware inputs. Here the address is I0.0. The proximity sensor is connected to the first digital input of the PLC, which address is I0.0. Now go for input output address. Here this address will be used in the PLC ladder diagram, and we can monitor the speed of the motor using this address. And now we have to make hardware configuration settings for analog output. The PLC we are using in this project has no analog output, so an external signal board for analog output have been mounted on this PLC device. So we have to configure this signal board. Click on the menu for signal board under hardware catalog. Click on the sub menu for analog output module. You will find the signal board here. Just drag and drop this signal board on this PLC device. Now select the analog output type as current. The current range has been automatically set to 0 to 20 mA. Set the output address from 100. This will complete the hardware configuration settings for analog output. Now we will proceed to make PLC ladder program for this project. Just follow the sequence for creating this ladder diagram. We have come to finish the PLC ladder diagram for this project. The normals and SCADA instruction have been used here to process the PLC analog output signal. To run the motor at variable speed, the user will give the set value range for motor speed from 0 to 100% in SCADA scheme. The normals and SCADA instruction then will map this set value range to 0 to 20 mA as PLC analog output, which will be applied to Arduino analog input to run the motor at variable speed. The speed measurement value found from the proximity sensor will be stored in the high-speed counter input address ID 1000, and this value will be processed by the move and division instruction to find the measurement value in measurement unit revolution per second. Finally, a multiplier instruction have been used to find the measurement value in measurement unit revolution per minute. Now let's go for creating the SCADA scheme using TI Portal software. The SCADA scheme will be created step by step so that you can easily follow the sequence. When we will complete creating the SCADA scheme and run this SCADA project on the PC, the user will be able to give the set value for motor speed in the SCADA scheme. The motor goes to run at the desired speed, and the speed will be displayed in the SCADA scheme as revolution per second and revolution per minute. Finally, I have come to finish creating my SCADA skin that you are looking at now. Now we'll run this SCADA project and perform our desired motor control operation and monitor the motor speed from this SCADA screen. So this is the video. I have tried to make you understand how we can use PLC high speed counter to measure the speed of a motor. If you find this video helpful for you, don't forget to subscribe this channel.